Bismillah ar-Rahman ar-Rahim. This is October 1942 variant, question number 3. And if you see the question, mass 0.3. So mass is 0.3. Okay. Held in equilibrium. All right. Magnitude is a 5 Newton acting upwards. Done. And particle attached to strings PA and PB. PA and PB. Correct. To two strings. And length is 0.9 meter, 1.2. Okay. And angle given 90 degrees. Sure. Find tension in each string. So we have two tension. When you say each string, so naturally, one more thing, interesting part. You have the same thing, but we have a ring here. Ring. Like this kind of ring. When we have ring here, tension in this string and tension in this string always equal. What's the why equal, sir? Because if it is a string and we have a ring here, a plug here. So tension in this part and tension in this part are equals to each other. This always equals to each other. Okay, it's very,
Sir,
very
this is
clear.
not a pulley.
No, it's not a pulley, my dear. It's not a pulley at all. But I'm telling you, whenever ring is there, ring. So tension are equal to each other. But when the ring is not there, this is a particle of P, like a particle P here. So this string cannot move. So it means tension in both strings are different to each other. So when I pull upwards and tension always away from it, I give this name as a T1. I give this name as a T2. Tension 1 and tension 2. So let's try to solve. Bismillah ar-Rahman ar-Rahim. Okay. First of all, these angles are very important to know. So for example, I make a right angle triangle. I believe, inshallah, you will understand 90 degree. This is 1.2. This is 0.9. I can find this angle theta. In front of theta is called opposite. In front of 90 is called hypotenuse. And this is called adjacent. So if I find adjacent by hypotenuse, opposite by adjacent, tan theta. So I'm writing here, tan theta is equals to 0.9 by 1.2. And when I get an angle from theta from here, so tan inverse, so 0.9 divided by 1.2, it giving me 36.87 degree. Okay, if I want to find the other angle, so it means this angle is very clear. I'm writing here 36.87 degree. Okay, I wrote here. And the other angle, naturally 90 minus that. Okay, let's see the other one. The other one is 90 minus that. So 90 minus this, or 180 minus both, no problem. It tends to be 53.13. Okay, this is very clear. Okay. So I think idea is clear. And now naturally, when for example, I think this diagram is very small. I make a big one so you can understand from here. Okay. So then you can understand well. Wait a minute, please. This is a lengthy. Okay. Because you must understand the diagram. Okay, my students. So what is the angle here? Here, angle 53.1, and this is tension 1. And this angle is 36.87, and this tension is T2. I think idea is clear. And this mass is pulling force is 5 upwards, but weight is acting downwards is 3 newtons. Why 3 newtons? Because 0.3 into 10, it becomes 3 newtons. So this is a P point. This is A point, this is a B point. This diagram is better to understand now. Otherwise, the first diagram is not that much effective. Okay. Now, after this, what to do? What to do after that? Actually, I have to resolve forces. Okay. I have a simple technique, because this arrow this left downwards. So I can say one force acting here, one force acting here. So, okay, one force. For example, if this force is here, one force component. But if this same force going this way, so what happens then? So one component this way and one component this way. I think you know it, resultant. X component, Y component, X component, Y component. So because this arrow comes downwards, So it means one arrow downwards and one arrow's left side. And this angle and this angle same. Why? Because when two lines are parallel to each other, so 53.1, and I can say here this 53.1. So in this sense, I'm writing here 53.1. So this angle and this angle, same reason, because this red line and this blue line are parallel to each other. So I think gradually you're understanding the all criterias. And let's complete the question. Okay, now this is angle given. So this is cos component T1 cos 53.1713, sorry, 13. Okay, and this downwards become T1 sine 53.13. Similarly, this also has two component, one this way. I show you one component this way and one component downwards. So this becomes T2, and this is again this angle and this angle same. And I'm saying here this becomes 36.87. So this becomes T2 cos 36.87, and downwards become T2 sine 36.87. Because system in equilibrium, he mentioned equilibrium. So I can say that upward force is equal to these three downward forces. Repeat, this force, second number, third number. And right, similarly, this is called vertical. Vertical means 5 upwards, 3 downwards, this downwards, and this downward. And what about horizontal forces? Right side force equal to left side force. So I think so I can make two equations. So first let's talk horizontal force. So let's start here. So first I talk horizontal forces, or horizontally. So what is horizontally? Left force equal to right foot force. So I can make a T1 subject or T2 subject, your wish. But I think this make easy. So T2 cos 36.87. I divide this whole thing down there. So what happens then? T1 is equals to, and let's see now, cos 36.87, this value divided by this value. So divided by cos 53.13, and it's giving me 1.3333 T2. Okay, so this is one equation is done. Actually, I brought it down and type in calculator. I got 1.33. Horizontally done. Now let's talk about vertically. Okay, vertically, what is that? Let's see. Upward force equal to downward plus downward plus downward. So 5 is equal to, I can say T1. So I think space issue. Okay, no problem. T1 sine 53.13 plus T2 sine 36.87 plus 3 newtons. These 3 newtons come from here, equals to top 5 newtons. So I think idea is very, very clear. So now I'm going to put this T1 value here. Okay. So when I put the value, so whole thing will come here. Okay. 1.3333 T2 times 2 sine of this. So sine 50. I'm doing simultaneous still. I'm just solving by simultaneous solutions. That is why it will take time only. Rest is very, very easy. Okay, this 3 goes there. I can make it 2. Now this T2 and this T2 common out. When I take T2 common out, what left in the bracket? This into this. So let's start. 1.3333 into sine of 53.13 and plus sine of 36.87 and equals to 2. Now this whole thing divided by 2, I will get my answer. And I'm writing here, T2 becomes, I'm typing directly my students, so let's see what answer comes. So 1.333 4 times into sine of 53.13, okay, plus sine 36.87, and I'm getting the answer 1.2 sharp newtons, exactly sharp. And this value, when I put it here, sorry, not it here, put it here. So let's see what answer comes. So put in 1. So I got tension 1, which is turned to be. So 1.2 times to 1.333, it becomes 1.56, 1.4, 1.6 newtons. So Alhamdulillah Rabbil Alameen, we got both forces accurately. Alhamdulillah, question completely finished.